Hello and welcome to lesson 2 of learning how to program in C#.net. Today we're going to be talking about variables, how we use them, what we use them for, and variable types. Before we jump into code, what I want to say is that C# is a static language. Now, when we talk about programming languages, we can normally categorize them. So the categories that are applicable here are dynamic and static. Now we are the latter of those two, and we'll quickly go over what that means, and we'll go over what types we can use in C# and what they represent. So let's jump straight into code. So, this may look a little daunting. Don't worry, we'll go over it. So, what do we mean when we say a static versus dynamic language? So, a static language, such as C#, choose C# out of our list of languages here. What we need to do is actually tell the compiler how to represent the data in memory. So, the way that we do this is by declaring what is known as a type. Now, types have what are known as keywords, so we can say that the first thing that we need to type is a type keyword. Then we need to give the variable a name or identifier. This is basically a human readable name. It can't start with numbers. It has to be alphanumerical, but it can't start with numbers. It can also start with underscores and @ symbols. Then we either have a semicolon, so this is one of the ways that you can declare a variable. Another way is that we have a type keyword, we have a name, which is our identifier, and then we can assign it a value. So the way that we assign values is through the equals, and then we give it a value. So how do we do this? So let's give our first type keyword. So int. Int is a type in C# that represents full numbers. It actually is short for integer, which is a mathematical term, I believe, for full numbers. So that is our type keyword. Next, we need to give it a name, so we can just call it name if we want to. And then we're going to assign it a value. Now, this just lit up in blue to tell me that this is a recognized keyword. And then we can just assign it 13 and then give the semicolon. We can also, if we wanted to, not give it an initial value. And what this will do is assign the type's default value. Now, each type has a different default value. The default value for integers is actually 0. Once we have a variable, we can actually manipulate or overwrite the data within that memory space. So you can think under the hoods, what the language is doing here is actually assigning the value of 13 into the computer, so a memory space inside the computer, and it has labeled it with the name. So what we want to do is tell the computer, hey, remember that memory address with the name? Well, I want to access it and I want to manipulate the data. So how the way that we can manipulate data is through any mathematical process. So we can say name and assign it the value. So we're assigning a new value to it, just as we were here. and then we can say that we want to take what is in name and then multiply it by 1. Now obviously we know this is going to be 13 because anything times 1 is the original value. So, but what this is going to do is say assign this memory address to the value of 13 times 1. And we can do the same with other mathematical operators. So we have plus, so this will be 14. We have divide, and we have name minus 1. And all of those are valid. Now there's kind of a shorthand way of doing this, where we can say plus equals 1, and this will be basically a shorter way of typing what is on line 8 here. A shorthand way of actually saying add 1 can be name plus plus. So this is actually a shorthand of what is on line 12. What we can't do though is say plus 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 plus, because that doesn't really make sense, although it's not flagging up any errors here. I'm sure that this hopefully won't work. If it does, then I'll be surprised. But to add something like 2, then we can go back to this shorthand. Now different types can hold different data. So let's take another type. Let's say string, for example, and let's call this my name. And then, like we did in the first lesson, where we said hello world, a string is just 2 quotes, and then in these 2 quotes, so we end this with a semicolon, we say hello world. And now these operators actually do different things in this context. So if we actually add equals exclamation mark, now if I was to look at my name, it would actually be hello world exclamation mark, because it has appended the exclamation mark on the end of my string. Different types have different ways of interpreting the mathematical operators. And when we come round to learning about classes, we'll learn how exactly these operators work. But for now, let's just say that they work by getting the memory address with this label, getting the value and timesing it by 1, or multiplying it, sorry, by 1. Multiplying is a better word than timesing. Okay, so this is cool. What other types of data can we represent in our program? And we're going to talk about some of their limitations. So this is where this comes in. So I've got a link here to the Microsoft Docs, where they've got some great documentation on every one of these types, but we'll kind of blast through these because these are available here if you want to go a bit more in depth than I am going to go here, but all of these are exactly the same as the integer in the way that you declare them. So by saying int name equals 13, we are assigning a memory address. to the value of 13, we can say the same as like a bool type here, where we're assigning true to that memory address, and then we're labeling that memory address with bool type. So types in C#. So here we've got an example. So this is exactly the same as we have here. So we've got data label, or this can be type. Type is maybe a better word there. And then we have a label, which is our name, and then we can either not assign it a value or assign it a value. So the types. So the first type that we have is a Boolean type. So a Boolean type is either 1 or 0. We represent this as 1 is true and 0 is false. And Boolean can hold either the keyword true or the keyword false. And that's it. That's all the values that can represent. Next we have a char, or I've heard it pronounced as car, that represents a character. Now this can be any character in the alphabet. It can even be representative of foreign characters. If this works, 1 second. Let me just, yeah, there we go. Yeah, so we can type in a Japanese character here. This is the Japanese character for wa. And that can be represented in our char. So anything within a single string, and we'll definitely be talking about the difference between a single quote and a double quote soon. Next, we have our integer type, which we just talked about on the other page, which I'll close right now. So an integer is a full number. Examples of this is -10, 10, 5, 6. Anything that hasn't got a decimal place can fit into an integer. And an integer, the integer type can represent numbers from -2 billion, I believe this is billion, to +2 billion. Now, we'll talk about why that is next lesson. But for now, let's just say those are the numbers that it can represent. Next, we have a floating point number that represents decimal place numbers. And it can represent anything from -3.40 to a 323 E38, which I believe is 38 zeros before the decimal place to positive that number, which I won't read again. Next we have a decimal, which is another way to represent decimal places. And the difference between this and a floating point number is just the accuracy in which it can save the decimal places. And it can represent this positive this number to negative this number. And one note I'd like to throw out straight away here, this is in the documentation. The decimal type value, the decimal value type is appropriate for financial calculations that require a large number of significant integral and fractional digits and no round-off errors. Just to throw that out there. Next we have the long. This is kind of the integer's brother in that it represents full numbers. So again, things like -10, 10, 5, 6, anything without a decimal place. but it can represent anything from minus this number to positive that number. So it represents a wider range of numbers. This is the integer's smaller cousin, the short. So this again can represent full numbers, but it can only represent 32 minus 32,000 to plus 32,000. This is the integer's very close sibling. So when we talk about numbers, we can say that they're either signed or unsigned. Signed means that they can go below 0. Unsigned means that they can't go below 0. So this represents anything from 0 upwards. Now if you take note here, this is actually just double the value of this. And again, we'll talk about that in the next lesson. The ulong is exactly the same as the uint, but for the long. So it represents 0 to this number, which is a very large number. The u short, which again is the unsigned short value. So it represents anything from 0 to 65,000. The byte, which is anything from 0 to 255. Now, this is actually the opposite way around to any of the other numbers, because this is actually an unsigned byte, but we don't have to say u byte. Instead, what we have is an s byte, which is a signed byte, which can represent anything from, this is minus 128 to 127. These are kind of a sneak peek into what's coming into the future when we talk about looping. We have what are known as arrays. This syntax is a bit complex for right now, but what we're saying is that we have a collection of integers, and we're saying that in this collection we have 5 integers, 0 through 4, and that is going to be represented through this name. And the way, just so that this is known, the way that we access this data, so as we were doing before, if we wanted to take the value of 0 and add 1 to it, so the value of 0, arrays actually start at 0, so they count from 0. So the way that we do this is access it through square braces. So we say, I want the first value of this array, and I want to add 1 to it. And that's how we do that. If we wanted to get the second value out of the array, then we would have 1, and this would return back 1. You know, if this was 4, it would return back 4. And we can do this with any type. So here's a character array. This is the symbol for array, and then we're adding A, B, C into there. Now, we'll definitely talk about this more in the future, but just so that you know, a string is a built-in type that is kind of different to the other types in C#. So what we've talked about today up until the string are value types. So value types, anything above there are value types. This is actually a reference type. And we'll definitely talk more about what that means in the future. But you can think of the string as a type kind of that is wrapped around a character array. So if I actually type hello, and then I say, and as I did before, if I wanted to take the first value out of the array, then I would do this. And this would be a character. Now I accidentally typed var, but character equals message 0. And this is just because the string kind of underneath the string is just a character array. This would be H. Now you just saw me type var automatically, and this is another way that we can represent data in C#. The way that this works is that it implies the type of variable from the type that you assign to it. So if I was to say I want to assign a string to the label hello in memory, then var would automatically become a string. But if I wanted to represent a number and say hello is now 1, this becomes an int 32, which is the same as the int. But what we can't do, and this here is the difference between a static language and a dynamic language, is that we can't change the type of the variable. So if we've declared it as an integer, as we have done with hello here, what we cannot do is then say hello equals a string value. That is invalid. And that right there is the difference between a static and a dynamic language, because in a dynamic world or a dynamic programming language, this actually would be valid syntax. Awesome. This has kind of been a lot, I know. I'm going to link to the documentation. Please read through it. You don't need to know all of the types that I've talked about today. Believe me, I have to actually learn about some of these types because I've never used them before. But it's good to know that they're there and what they represent in our programming language. And we'll be using these moving forward to represent things in our program. So if we ever need a number, we'll use an int. If we ever use a string or a message in our program, we'll use a string, so that these types kind of get hammered into your brain. That this is kind of foundational knowledge that we'll have to know moving forward. Thanks for watching and supporting this series. Hopefully you're enjoying it so far. I actually lost a bunch of episodes. You'll see in my projects that I actually got up to lesson 5 and I lost all the videos from 2 to 5, so I'll have to catch up a little bit with myself. Hopefully you enjoyed. We'll see you next time.